if the positive integer c has the positive integer divisors a and b with c equals a times b, then a and b are said to be complementary divisors of c. Suppose that n is a positive integer that has one complementary pair of divisors that differ by 20, and another pair of complementary divisors that differ by 23. What is the sum of the digits of n? Okay, so on the one hand, n can be written as n equals a times a plus 20. On the other hand, it can also be written as b times b plus 23. Let's try to solve for a and b. First of all, you can easily observe that a is greater than b, right? Because otherwise, left-hand side is always smaller than the right-hand side, and they cannot be equal to each other. Or this term cannot equal to this term otherwise, okay? Next, let's expand this. So we have a squared plus 20a equals b squared plus 23b, right? Let's move b squared plus 20b on the left to get a left-hand side equals a squared minus b squared plus 20a minus 20b equals 3b. And then from difference of squares, this is a minus b times a plus b. And this term is 20 parentheses a minus b. And if we pull out a minus b, we can just write the left-hand side as a minus b times a plus b plus 20 equals 3b. Okay. Now, I'm going to, okay, so let's, for a moment, let's observe this quantity. This is at least as big as b plus 1 plus b plus 20. Because a is at least, a is bigger than b, so a is at least b plus 1. And then we just replaced a by b plus 1. So this quantity is 2b plus 21. Okay. And then let's write an inequality. So 3b is greater or equal to than a minus b times 2b plus 21. Now, or I mean, you can just divide both sides. So we get a minus b is less or equal to than 3b over 2b plus 21. And we see that this quantity is strictly less than 2. Means a minus b is less than 2. On the one hand, on the other hand, we know that a minus b is at least 1. Okay. That means a minus b has to be 1. Let's substitute a equals b plus 1 back into the equation, that we got here. So this blue that I just marked in blue. And then we get, so let's see what we get. We substitute it. We get 1 times 2b plus 21, 2b plus 21 equals 3b. And from here, let's solve for b. And we get, when we do it, we get b equals 21 immediately. And then the number is 21 times 44 equals 22 times 42. And this actually works. So this works. And the product of those two numbers is 924. And the sum of the digits of n is 9 plus 2 plus 4 equals 15. 15 is our answer, which is C.